How can Antarctic ice cores, what do they reveal about pollution and history? Hello friends, Jim here. An article published in EOS, Antarctic ice cores capture heavy metal pollution and history. An ice core record going back 2 millennia hints at the mining and metallurgy that waxed and waned with events such as wars and epidemics. So here we have ice cores being stored in the McConnell lab in Reno, Nevada. And, various sorts of indications on it. It looks like segments 104, 105, 106, etc. And the arrows are telling which way to put the things together. So ice cores, they're pretty much used like the way tree rings are. You can, recreate what took place in the past. And in Antarctica, cores have revealed a 2,000-year record of heavy metal fallout from the southern hemisphere. Levels of toxic metals such as lead and cadmium, produced by mining and metallurgy, dramatically increased after the Spanish conquest of the Inca in the 16th century, according to new research. Brief downturns coincided with events such as war and the outbreak of disease. These findings shed new light on how environmental changes are linked to history in the southern hemisphere. Now, Joseph McConnell is an environmental scientist at the Desert Research Institute in Reno, Nevada. His colleagues analyzed the chemical composition of ice cores by, an easy heating of the cores, taking the melt water and basically running it through various, instruments, probably gas chromatographs, mass spectrometers, and so forth. And their machinery is able to detect the presence of elements and compounds with just a few parts per trillion or even quadrillion, which is pretty damn amazing. McConnell and his collaborators, I prefer the term colleagues, recently analyzed a suite of ice cores drilled from 5 different sites in East Antarctica between 2013 and 2021. They focus on the uppermost 100 to 150 meters of each ice core, which encompass the snow that fell over Antarctica for the past 2 millennia. Heavy metal particles created by activities such as fossil fuel burning, mining, metallurgy show up in ice cores because the particulates basically attach themselves to dust grains, and the dust grains themselves are carried along by air currents, and often for considerable distances, many, many kilometers, before precipitation, rainwater, for example, washing them out of the atmosphere where they're deposited on the surface. McConnell and his colleagues used atmospheric modeling to show that dust grains found in East Antarctica could have easily traveled from the nearest inhabited land masses, Australia and South America, in just 1 to 2 weeks. The researchers precisely measured the concentration of various elements in their 5 ice cores. They applied a timestamp to each of those measurements by correlating the timing of known volcanic eruptions with the signatures of volcanic fallout observed in the cores. They focus on 3 specific heavy metals: lead, cadmium, bismuth. Those elements can be produced by mining and metallurgy. So, for example, if you're mining for silver, then you have to go through an awful lot of lead-containing material. Typically, you're having a 10,000 to 1 ratio of, lead to silver. In other words, you're going to end up processing 10,000 parts of lead for every 1 part of silver obtained. Lead, cadmium, and bismuth are also released by both normal rock weathering and volcanic activity. These natural sources can significantly contribute to the background levels of heavy metals in the atmosphere, said Mariusz Potocki, a glaciochemist at the University of Maine, not involved. So, to account for those sources, basically the background noise, McConnell and his colleagues corrected their data on the basis of measurements of cerium and thallium in the same ice cores. Those elements trace rock weathering and volcanism, respectively. So, by knowing that, they can then make the appropriate corrections. And that was very important for this study, making the analysis and the deductions possible. The ice cores showed that concentrations of lead began increasing in the 1200s. A consistent, pronounced increase, nearly 3 times the levels measured from 1 to 400 CE, persisted by the beginning of the 17th century, which makes sense according to the researchers. So they suggest the Inca Empire had fallen to the Spanish in the 16th century, and the colonizers wasted no time developing extensive mining operations in South America to extract metals, such as silver, which they sent back as bullion. And here's a photo of a silver mine in Bolivia. One of those operations was the Potosi silver mine, which went on to produce a significant fraction of the world's silver. Cadmium and bismuth also showed smaller but still consistent increases by the beginning of the 17th century, the team noted. By the middle of the 19th century, the concentrations of all the 3 heavy metals had risen by at least a factor of 10 above early Common Era levels. Much of the more recent heavy metal pollution could be ascribed to the onset of lead mining in Australia and tin mining in Bolivia. When McConnell and his team examined the data more closely, they noticed some various dips in the data. For starters, lead, cadmium, and bismuth concentrations all decreased in the late 1580s. Well, that happened to correspond to what's called the Andean epidemic, a disease outbreak of either smallpox or measles. This is a widespread disease among indigenous peoples, and the labor force working in South American mines would have likely affected silver production and therefore the emissions of heavy metals. So basically, it's pretty wild. McConnell said that a pandemic in the Andes in the early 1500s altered pollution in Antarctica. In the early 19th century, lead and cadmium levels dropped again after South American wars of independence. Those battles damaged mining infrastructure and curbed international investments in South American mining. Their study was published in Science of the Total Environment. These results highlight the far-reaching impacts of anthropogenic activity. They are not only credible, but also emphasize the extent of human influence on the environment, said Pataki. In the future, it'd be valuable to investigate how the biology and ecology of a place are affected by heavy metal deposition. This goes to show you how everything is interconnected on this planet. They don't just happen locally. The air and the oceans are a coupled system. Something happens in the air, if something happens in the ground, it gets into the air, it gets into the ocean, it gets into Antarctica, it moves all over the place. We see pollution that originated in one locale, literally halfway around the planet in another locale. And that's kind of what I think to be well, this is very interesting to trace that. and it's important. We can see the level of pollution and so on. I think the real takeaway message of this is just how interconnected this whole planet is. One huge system. And I think that is often underappreciated. So I found this to be interesting, and I just wanted to share this with you. Hope you found it interesting as well. Until next time, thank you for your time.